Hey guys, how's it going? In my voxel game, I've been tackling the challenge of efficiently managing and rendering voxels. And today, I'll peel back the layers and unveil the inner workings of my merging algorithm, a technique I've been using to merge, split, and handle disconnections of these voxels. Before we dive in, let's quickly go over what voxel cuboids are. Imagine a 3D space filled with tiny cubes called voxels. When you group these voxels together, you create a larger cuboid shape. For example, a 2x2x2 cuboid would consist of 8 voxels. Simple, right? Now let's unpack the merging algorithm, which is at the heart of our voxel cuboid management system. The core idea is to merge neighboring cuboids into larger ones in a specific order. The key to merging cuboids lies in the merge cuboids method, which takes 2 cuboids as input and returns any merged cuboids if possible, or null if they cannot be merged. Now let's see how merge cuboids works. The method first checks if the bounds are adjacent along the x-axis by comparing their positions and dimensions. Specifically, it checks if the sum of the x dimension and x position of one bound is equal to the x position of the other bound and vice versa. If the bounds are adjacent along the x-axis and their y and z dimensions and positions are equal, then they can be merged along the x-axis. If merging along the x-axis is not possible, the method checks for adjacency and mergeability along the y-axis, following a similar logic to the x-axis check. Finally, if neither x nor y merges are possible, it checks for mergeability along the z-axis. If none of the axes allow for merging, the method returns null, indicating that the bounds cannot be merged. Now let's look at how we handle the removal of bound and deal with potential disconnections. The remove bound method first checks if the bounds to be removed overlaps or is contained within any existing bound. If so, it splits the overlapping bounds into multiple smaller bounds using the split bound method. After removing the target bound, we check for disconnected components using the getConnectedComponents and DFS method. If disconnected components are found, we create new instances for each disconnected component and add them as a separate game objects and apply physics properties like rigid body to allow independent movement. While it's not the most optimal solution out there, it serves a solid foundation for understanding voxel cuboid rendering and management. Thanks for watching.